Assalamualaikum. Today we discuss the topic physics numericals that is related to the chapter AC circuit. The first numerical that is we discussed that is the peak voltage of AC supply is 300 volt. What is the root mean square voltage? Here is the peak voltage given. So peak voltage is denoted by 300 volt. What is the root mean square voltage? We find the root mean square voltage. We know the formula of root mean square voltage that is equal to V naught over under root 2. Here V naught that is given 300 over under root 2. So here we get the answer of root mean square voltage is 212.1 volt. That is the root mean square voltage find by given data. Okay, now move to the next numerical. In the next numerical, they ask the root mean square value of current in AC circuit is 10 ampere. What is the peak current? It's given that the root mean square value of the current is given. Root mean square value of the current is denoted by IRMS. That is given 10 ampere. Here we find the peak current that is denoted by I naught, and we know the formula of the root mean square current that is the I root mean square current I naught over under root 2. Here we find the I naught, so we rearrange the formula of the root mean square current for find the value of the peak current. Here the root mean square current that is given is 10 multiplied by under root 2, 10 times under root 2. If we calculate it with the calculator, we find the answer 14.1 ampere. That is the peak current that we find by given data. Okay, now move to the third numerical. In third numerical, that is given that the AC voltage across a 0.5 microfarad capacitor is 16 sin 2 into 10 to the power 3 t volt. Find the capacitance, capacitive reactance, and B option B is find the peak value of the current. Here the capacitor value that is the 0.5 microfarad and AC voltage applied across the capacitor that is the 16 sin 2 into 10 to the power 3 t volt. First find the capacitive reactance and second find the peak value of the current. So here we find first the capacitive reactance. We know the formula of the capacitive reactance that is the 1 over omega C. Here we find the omega by formula that is this applied voltage across the. We compare this equation by V is equal to V naught sine of omega t. So if we compare these two equations, omega to 10 to the power 3 that is equal to 2 10 to the power 3 that is equal to omega. So here is the omega value that is equal to 2 into 10 to the power 3 and C that is given 0.5 microfarad and microfarad. We know that that is equal to 10 into 10 to the power 6 minus 6 farad. So here minus 6 farad. So if we use the calculator, we find the that is capacitive reactance that is equal to 10 to the power 3 ohm. That is also right as 1000 ohm. Okay, here now we find the peak current. We know the formula. Here if we compare these two equations, so V naught that is equal to 16. So here V naught that is equal to 16. So while using the formula, V naught is equal to I naught XC, that is basically the Ohm law. Here with resistance, we use the capacitive reactance resistance, that is the XC. So we can find the I naught by using this formula. I naught is equal to V naught over XC. V naught that is given is 16. SC that we find 1000 ohm. So we get the I naught that is equal to 0.016 ampere. That is the value of the peak current